Thank you so much. So we're going to change the format a little bit. The other speakers got to stand. We get to relax a little bit. So they got us chairs, and we get to have a conversation. So this will be less about slides and more a conversation that you'll hear directly from some of the stories we're doing. Just a little bit about myself. Steve gave an intro. Our team, we build a lot of agents. We're called forward deployed engineers. And most of the time, what we do with our customers across industries, manufacturing being a big one, is work with customers, work and identify the problem, and build agents with them. So we've had, I think, over the course of the last several years, we must have built several thousand agents. And it's been fascinating to learn what an agent is and how it really drives business and outcomes for our customers. But sometimes it's just good to step back and say, okay, what are we talking about? There's a lot of talk about agents. Like, it's always good to level set. I can guarantee you, if I spoke with 5 of you and asked you to define an agent, I'll get slightly different answers. So I just want to level set for this conversation what we mean by an agent. And effectively, what we're saying here is an AI agent is nothing magical. It's a software application given a goal. And using that goal, it looks around its environments, builds context is a formal word. And using that context, reaches out to a whole bunch of tools and gets the job done. So the goal is to how do we get beyond chatbots, right? In the immortal words of Eli Wallach, if you want to shoot, don't talk. Get actions done. And a lot of our customers are like, hey, I want to get actions going. And the 4 building blocks for agents, and there's been a lot of research happening, and we are nowhere close to done, right? And every week there's new innovations that are happening across every one of these building blocks. And I'll talk about some of the key hot words that are happening right now. Every AI agent, the software application, its brain is most likely an AI model. It's one of these big frontier models, or depending on the use case, maybe even some of the smaller models as well. That's number one. Second is it has access to a variety of APIs and systems it needs to connect. Formally in agent language, it's called tools. The third is how do you orchestrate the actions of the LLM calls and these tool calls is usually done through some kind of an orchestration. The formal word for that, if you want to sound cool in 2026, or at least this week, is called harness engineering. So you cannot not use the word harness anymore. But fundamentally, that's what orchestration is. Okay? You're using a harness to drive these agents around. And a runtime where you safely run these, right? Because agents are going to perform tasks on our behalf. You heard some incredible stories, but some of these are reading grid details, right, from a story that came before. Or you have a health remediation agent in the BMS use case. So how do you trust who this agent is and have a secure runtime to run this? Each of these agents are given a task. There's a profile, there's goals, they keep track of memory. We'll speak a lot about memory with Jonathan and how knowledge graphs can play a big role in improving the quality of these things. So that's the building blocks for the agents. And these agents can be organized in many ways. You could have a single agent talking to a lot of systems, a lot of tools, or you can organize them just like you'd organize a team where you have multiple agents talking to each other, usually orchestrated in some form or shape. You'd have a root agent, with a bunch of sub-agents. And this is a very, very common pattern, something that Jonathan will talk about as well, that he's doing, within his company. Now, one of the challenges that happened in the last year is as the number of AI agents grew like crazy, we have customers who went from 0 agents to thousands of agents in a span of 3 to 4 months. And all of a sudden, these agents are hungry. They're trying to reach out to all your systems. And it became really untenable. There's been the emergence of a protocol called Model Context Protocol, right? Again, it's had its ups and downs. There's a lot of merit to it. I think there was late last year was a peak of MCP hype. But, WISER councils have prevailed right now, and where people are like, hey, this is where MCP is a good fit, where it's not. Again, we'll talk to Jonathan about his use of MCP and how we see it, in the wild as well. So MCP has become a really crucial point. This is an example that we had built. Effectively, if you see the end user on the left side wants to perform a series of actions, do deep analysis by reading Reddit, hopefully filtered version of Reddit, connecting to a lot of our own cloud information, doing web searches. But the right side is partly mediated by MCP, partly mediated by APIs. And right in the middle, effectively, is an open source-based agentic framework with a multi-agent system that connects to and does these things, right? So this pattern that you see here is, and I'm sure a lot of these stories that I shared today, followed some variation of this pattern, right? And the reason I share this is systems like these are prevalent in pretty much everything we see in the manufacturing and the supply chain space, right? So procurement, PLM systems, manufacturing, shipping, delivery, no matter which which sub-industry you are in manufacturing, you probably have a lot of these things. And what we've seen is our customers saying, hey, how can I use these agentic architectures? How can I use these agentic architectures combined with MCP to either automate sub-processes within each of these or zoom out and more holistically automate processes across my end-to-end supply chain, right? And it's been a fascinating run to watch the evolution of truly automated subsystems, look at each aspects of these and drive outcomes. So with that, I was super excited to chat with Jonathan. Jonathan is both a customer of us, Google Cloud, but more importantly, a deep practitioner. Now, don't let the title of Hillspire confuse you. He spends most of his day job, night job, and everything in between, working for a company called Relativity Space. It's probably a couple of reasons. Number one, they're using AI agents to build AI data centers, to take those AI data centers and put them in the cloud. So it's AI agents for data centers that will eventually sit in the cloud somewhere in orbit. So I don't know, it sounds pretty cool to me. So we thought we'd chat a little bit and riff back and forth around what Relativity Space is doing and how AI agents are helping. But I'll let Jonathan do a detailed introduction of himself and share a little bit more about what he's been working on.
Thank you so much, Arni, for the introduction, and it's a pleasure to be here. It is indeed the coolest job to work in an aerospace company and work in the AI innovation, so very, very much agreed with that, and it's been a fantastic journey. A lot what we've learned through our AI journey is that in the creating this agent framework around the ability to build the agents and fulfill various functions throughout the organization, from supply chain to finance to manufacturing to tax to whatever other work exists in the end-to-end manufacturing space, advanced manufacturing space, is really creating an innovation cycle. Right, we want to be able to build the agentic framework and we've built an agentic framework that enables our employees or users to utilize their imagination of what tasks they want to be able to automate. And so in reality, what we've delivered to them is a framework where they can use markdown files and in plain English articulate functions they want to be able to automate, because that in itself becomes an element of mushrooming these agents. Right? I don't know how many we have right now, because there could be hundreds and there could be thousands, because there really are. That in itself, I think, is a really important factor. Right? Give our employees, give our users ability to innovate on their own. I have a bunch of ideas of what they think we can do for them and help them out. But in reality, what becomes very interesting is that once we give them the tool, that framework of innovation becomes really important. I will also say that lots of lessons learned through this exercise, and most of the commercially available agentic frameworks are great for prototyping. They're not great at deployment and scale. They just don't work. They look great in demos, and then you start using them in production environment, and you truly realize it doesn't scale. So we've opted to build our own. But we've built them on top of the open source and open architecture and open standards, such as MCP and others, and skills that are becoming standardized as MD files, in ways of being able to communicate between the systems of record and our agentic framework. We've also taken the approach of building a learning orchestration layer. What does that mean? So we analyze from the underlying systems of record all the activities that are happening there, and using machine learning techniques to empower users with ideas of what can be automated. What are the possible patterns we can detect in the underlying systems of record that we could utilize in improving our user productivity and organizational productivity? And I also want to talk about the knowledge graph and how that plays a big role, an ontology layer, how that plays a big role in the architecture of what we've built. Truly, we want the agents not to be a kind of entry-level interns, but knowledge experts, right? They're really understanding not only what the underlying systems are used for, but also what happens in the tribal knowledge in between the systems, in those emails, Slack messages, or other methods of communication between employees. So we want to capture all of that in an end-to-end architecture to ensure that folks can actually access that information, and the agents can actually access that information in a robust fashion.
Yeah.
So lots of good lessons learned.
Yeah, excellent. I think one of the big patterns we've been seeing as well as a part of our deployments is as the number of systems that these agents need to connect increase, and the complexity of the data that's inside these, and we have some customers who have, for the life of me, I don't know, and maybe some of you here have 55 to 60 ERP systems. And that's a lot of systems, right? And each of them have varying records, varying schematics of what the information is stored there. There's been a market increase in customers who are willing to build an ontology that rides on top of these systems and provide a much more intelligent context, because building context is going to be extremely important for these AI models. For a couple of reasons. Number one is if you know how LLMs work, they have a context window. Yes, the context window has been growing. It used to be 126, K, 256K, and now you have a million context window. But even with a million context window, the number of words or tokens you can squeeze in, they're not really good at reading the entire million words. They're really good at reading the front, maybe the back, but you kind of get lost in the middle. It's formally called the needle in a haystack problem. And you need to make sure that you're providing the AI model, the LLM, the best information right at the top so it can act on that really well. And ontologies have been around for a while. They've been hard to build. They've been hard to create. But it turns out for some domains, building an ontology goes a long way towards making these agents have the right context to answer the questions. So question for you, Jonathan. I've seen this work and also have seen this not work. What are the techniques that your teams have deployed to make sure that the ontology that is riding on top of the various systems, works really well? That's question number one. And is there a correlation or a connection between the rollout of MCP as the AI agent to the AI, the various tools glue, with the ontology as well? Are there threads that connect them? But maybe start with the ontology first.
I think the ontology is an interesting topic, right? You could design your AI agents without the ontology. It will work, but you're not going to be happy with the results. Ultimately, that expert knowledge, the capturing of the relationship between objects from a bill of material to execution and manufacturing processes, all has to live someplace.
Yeah.
And the ontology becomes that brain of your factory, the brain of your manufacturing processes that need to be need to be understood and learned by your AI agents. So, and in addition to that, the decisions that your AI agents make need to be captured in that ontology layer as well, so that those decisions get better and better and get optimized. So that self-learning optimization becomes really critical through the ontology implementation. But the other thing I'll say about the ontology, it needs to be learned. It cannot be a static brain, right? It has to become continuously evolving and learning from the underlying systems, as well as the decisions that the AI agents implement. There are lots of really great open source implementations of ontology. There's some commercial versions as well. Building one in-house is very challenging. I don't recommend that. But obviously, they're utilizing Neo4j or some such will work quite well and will scale for your business. But that becomes a brain of your operation, a brain of your organization as well. And it will not only, but think of ontology as not as the understanding the underlying operations in your systems of record, your ERP, your manufacturing execution, your SCADA, but truly what lives in between those systems as well. That tribal knowledge that doesn't often get captured in any of these systems, that lives in the brains of some of your employees as well. How can you get that data in this unified ontology layer becomes a really interesting and challenging task. If you achieve that, I think you'll get a really great result. And that's one of the lessons we've learned through this exercise.
That's great. Yeah, before we double click into the MCP side, one of the big trends we are seeing, building on what Jonathan said, is this notion of continual learning. Historically in AML, continual learning is when the system learns from what is happening and goes and updates the model weights. Now, when your model has maybe several thousand, couple of million weights, easy to update, maybe, but it has downstream implications. But when your model is not yours to begin with, or even if you have an open source model, like a Gemma or a model like that, the model weights are way too big. And continual learning at the model level becomes unsustainable and probably even not realistic. So the last 3 to 4 months, maybe even a little more than that, we saw a pretty big uptick in continual learning techniques being applied, not at the model level, but at the harness level. So in between where the work happens and where the model operates. So double clicking again on what you said is, and just connecting it back, your ontology is not a static artifact. Your ontology is changing in two distinct ways. Way number one is the ontology is getting modified from the source data that is being fed to it, because the underlying systems, your ERP and other systems or PLM systems are always changing, so the ontology is changing as a result of that. That's one part of it. The other part of it is as decisions are made at various points in time, these agents are performing a goal, they're completing a decision, taking an action, and they're learning from that. You'll have a human in the loop, and the human may come back and say, yeah, that was great, that was not so great. Now, ideally, you want to store that information in a system, which is the context engineering, which could be part of the knowledge graph. So as we build these systems, make sure that you have a continual learning loop. And I'd say a year ago, there was a lot of interest in doing continued pre-training or fine-tuning of the models, but more and more customers have started to go away from that unless you have a very specific reason to do it, and do continual learning more at the agentic layer and the knowledge and the context layer than at the layer below that. So I don't know if that
No,
builds on top
absolutely.
of
I
what
think
you
this
just
makes a
shared.
lot of sense. I also want to differentiate between agent memory as well as the ontology layer.
Correct.
Agent memory is an interesting component, right? It becomes, I don't know if all of you have used ChatGPT and Claude, I'm sure all these systems capture who you are and what your birthday is, when your siblings are, et cetera, et cetera. The agent memory in a context of orchestration for advanced manufacturing, or what we're trying to discuss here, is really about what tasks it has been able to complete and how, and doing so successfully. So that is very interesting, because then it becomes the optimization element of it. Reinforcement loop is really not done in a form of LLM, but in a form of that memory layer that lives on top of it. So that memory becomes very useful, so that if we have found a way of completing a certain task in a faster, more efficient fashion, efficient from both the token utilization, or efficient from more reasoning or agentic layers, we want to capture that, and we want to reuse that in the future as well. So that agent memory becomes really important for that type of reinforcement loop, for that type of learning orchestration. The other thing that I want to mention is that memory becomes shared, right? Because you have multiple users. You don't want to isolate it to a specific employee or user within the organization, because it's not really, has nothing to do with that user or employee. It has everything to do with the functions that you try to accomplish, and you want them to improve over time as much as possible. I find that the MD file architecture is not as scalable as I'd like it to be. So there's lots of some of the limitations. I'll spare you the technical details of the limitations of agentic orchestration, but I think there's a lot of opportunities for innovation there as well. But I do want to talk about MCP, and I am a big fan of it. Since the release in 2024, I've been using it quite heavily. I find that MCP becomes a huge unlock in connectivity between the large language models and the underlying systems of record, or underlying databases as well. And not only in your ability to be able to perform read-only type of operations from your systems of record, but also read-write. Could you optimize? There's opportunities for optimization as well, and it's gotten more and more robust. One thing I'll say about MCP, the joke about MCP, there's no S in MCP, there's no security in it. And so we had to build our own security and authentication and authorization layer around that. With that in mind, and it can operate in a context of particular users' credentials. So if you solve that problem, you will get a lot of really positive results in utilizing MCP as an underlying protocol. And the other thing I'll say about LLMs as well, the non-deterministic nature of LLMs makes it very challenging for you to use it for deterministic type of functions. So I like to use LLMs with a lower temperature, which means the creativity vector is a little slower, but it produces more deterministic results. And harness engineering becomes at core of solving this problem, back to what Arni said earlier.
Yeah. Yeah, I think that's an amazing point. I mean, one of the things I did see with our customers is, most of enterprises run on deterministic workflows, with some of the non-determinism coming from us as humans as you make judgment calls. But the reality is when they say, hey, we want to deploy AI agents, they make a full binary flip and said, hey, we're going to take all these deterministic workflows and make them completely non-deterministic. And I'm like, why would we go from all the way from left all the way to the right? So what really works well is frameworks that can manage both of them seamlessly. And you always, depending on the process, you probably always want to have a human in the loop at the right, doesn't need to happen at the end, can happen at key points in the middle. But obviously, as Google, we've released a bunch of open source frameworks. The community is largely rallied around, hey, how do you have a blend of deterministic and non-deterministic? Good old, if then else loops. There's nothing wrong with if then else loops. It almost seems like in 2025, we said if then else loop is bad, and everything has to be non-deterministic. Not really, right? So determinism matters, but how do you blend both of them and get the most out of both of those environments, right? That's a big point number one that we saw, as we are deploying it. The second one, which again you highlighted, Jonathan, is identity. Now, MCP or not, you need to be thinking deeply about agent identity because your agents are going to be talking to backend systems, and more agents are going to perform actions on our behalf. So let's say we had a bunch of customers that do supplier relations, and they automate negotiations with a variety of suppliers. Now, in this case, this agent is acting on behalf of a procurement officer and making deterministic calls to say, hey, I'm going to approve this, not approve this, the price is too high, the price is too low. Now, in this case, the actions being performed are on behalf of this human. And tomorrow, when an agent approves a $500 million purchase order, you want to make sure that this is, and if it's being done on behalf of a human, that the human knows this action is truly happening and has authorized it. So there's a lot happening in the space of agent identity. There's several standards coming out, existing standards being extended, right? So for example, there's an on behalf of extension being done in the OAuth community. We as Google launched a bunch of open source ones building on top of SPIFFE, which is a known identity standard. But the caution I'd say is as you dial up the number of AI agents within your environments, the POCs and the demos will look amazing. By default, just don't believe anything, right? Because it's so easy to build demos nowadays that it's almost scary what it almost looks real and ready, but none of that works when it's hit, meets the reality of the true enterprise. So think about agent security, think about agent identity, and think about the agent identity call flow from start through finish. Because you could have MCP servers along the way, and you want to make sure that that MCP server, if it's in the call path, has identity baked in because calls will be made on behalf of the agent to a backend system that is most likely mediated by an MCP server. So these are a lot of hard lessons that at least we've learned, building this out. And then the third and the last piece that you had brought up, which is the last, I'd say, 6 months, we've seen a dramatic uptick in Markdown as a programming language, which is true, right? I think Karpathy, if you don't follow Andhra Karpathy, he's certainly a legend in the space of AI, and I think he's the man who gets retweeted and liked the most quickly. The minute he says something, it joins the AI zeitgeist pretty quickly. And he had said 2.5 years ago, English is the new programming language. And I think what he really meant is Markdown is the new programming language. So we are seeing more and more agents being created using Markdown. But again, it's the binary, right? So we went from heavy high code agents to hey, maybe you can just do Markdown. You can go from completely non-deterministic agents to deterministic agents. The reality is somewhere in the middle. So we are seeing customers use a combination of Markdown and agentic APIs, a combination of determinism and non-determinism work. So finding the right balance will vary by the use case, but you'll need to use both, right? So we have a lot of customers like, I just want to use Markdown and complete non-determinism, and that's just simply not going to work. So just closing this out from a people standpoint, obviously you're sitting at the cutting edge, you have some incredible talent, but still it's a manufacturing environment. What has been the enablement path? How much have you been able to give to the employees and said, hey, build this all by yourself, as against to, oh my God, they're building 800 agents. What are they going to do? Like, what has been the independence you've offered to the employees as they build these things out?
We want to foster the innovation cycles. And fostering the innovation cycle starts with the ability to give employees the playground to build what they want to be able to do. So identifying those who are willing to embrace the cycles of innovation and partnering with them through this journey became very important for us. But also verifying that these Markdown files are actually built in a thoughtful way. There have to be checks and balances in place. Also ensuring that, so some guardrails that we've established and some rules of the engagement and compliance elements, right? So for example, the PO approvals do not happen by the agents. Financial approvals are still going through the human in a loop and analysis by the humans who we're actually verifying the POs are correct and then approving them. But we also maintain that we use Confluence for maintaining the compliance documentation that defines what are the constraints, what is allowed, what isn't allowed, and that's fed into the ontology layer that then describes what are the rules of the engagement and how we use to use those agents. But partnering with key stakeholders in each and every group, supply chain, manufacturing, finance, whatever else there may be, other groups are, and enabling them to, and you train the trainers, and then they start showing it to their colleagues who are then getting excited as well about using that. And that becomes kind of this natural evolution, natural innovation cycle. Right, folks are saying, "Oh, I'm doing this every day now." We've also built a mechanism whereby we're learning the audit trail from the underlying systems of record and creating recommendations for what we think can be automated as well. And folks really like that because it enables them to see what are the opportunities that we have in front of them to be able to adopt the particular agent recommendations that are coming through. But overall, partnering with those who are interested, partnering with those who have had success with it, and failures. And there's a lot of learning from that as well. Yeah. Some agents work, some don't, and you figure out what doesn't work, and then you improvise and you improve and innovate.
Excellent. We'll close this out with a minute left. Infrastructure for agents is growing at a breakneck pace. Agents are very power hungry and token hungry. So we as Google have seen, as customers have deployed more agents, the dramatic spike in token usage. So account for token budgets appropriately. I think we just announced last week that Google is shipping out 16 billion tokens a minute. It's just like, for me, that's a staggering number when I see that. So with that, this question that we did not rehearse, I wanted to see what Jonathan says. When do you think the first data center in space is going to go up? You're right at the forefront of it.
I don't know. I'm anticipating. I'm certainly hoping in our lifetime. I'm certainly hoping it'll happen in our lifetime.
That's amazing. With less than a minute left, any open questions? Hopefully you benefited from the dialogue. We'll be outside. If you have any more questions, feel free to reach out. But any questions? Yeah.
Hi, Krishna started a story. Thanks for your insights. On ontology, you mentioned you build the ontology with the agents. Usually when you have one, it becomes incredibly useful, but to create one becomes an exercise unto itself. How do you strike that balance?
I think we've built a mechanism where the ontology is discovered automatically. We use MCP to build the ontology from the systems of record, and then we build custom processes that ingest that tribal knowledge that we try to. So automate that as much as you can, because I think if the ontology becomes a static organism that is very hard-coded into your existing processes, that's not going to work. So finding ways for it to be much more of a living organ that updates itself and learns from the underlying systems, learns from the tribal knowledge of the employees, or from your Slack messages and other systems within the platform, within your environment, becomes really key. Of course, data privacy becomes really important as well. But that would be that's the approach we've taken, and that's the approach that we believe works.
I'll take one last one before we get yanked. Yeah. Yeah, good.
I think, golden source of rule. There has to be, out of the 29 systems, there's got to be one that says this is the actual source of truth about different objects you have, right? That becomes more of a data governance consideration as opposed to the actual AI problem. I think, again, a lot what you do with AI becomes data hygiene, data governance, right? So once you think through how that's established, and which I'm sure you have, you'll get a greater success of that. But I think you can't hard code necessarily the rules, right? They have to be learned. But there may be from time to time, there may need to be corrections that are updated in the ontology that basically say, okay, well, this is how we view, these are the objects, and this is how they relate to one another, and these are the ones we consider to be important, and this is what they mean.
Yeah, we can double click on that. Obviously we're on our time, but there's a lot of talk about data for AI, but we are seeing so much interest in AI for data. Like, hey, how do I use AI to improve the quality of my data, both at static time and at runtime? So if a decision was made and you're like, that's the wrong answer, and is the answer wrong because the data was wrong, or did something else? If the answer is because the data is wrong, using AI to go fix that. So that continual learning goes back and is helping not just the ontology that rides on top, but the data that feeds that ontology as well. So it takes work, but we are seeing that AI and data continuum truly play out, right, in the enterprise. Excellent. Thank you so much. Yeah.
Thank you.